Imagine looking up into the deep, dark velvet of the night sky. The familiar stars are there, tiny pinpricks of ancient light scattered like diamonds on black cloth. But tonight, something is different. A new star has appeared, a fuzzy, bright smudge against the darkness with a long, beautiful tail stretching out behind it. This is a comet, a magnificent visitor from the farthest, coldest reaches of our solar system. It is a traveler on an immense journey, and for a short time, its path crosses ours, giving us a spectacular show. These celestial wanderers are more than just pretty lights. They are time capsules, carrying secrets from the very dawn of our solar system, billions of years ago. So, what exactly is a comet? In the simplest of terms, a comet is a dirty snowball hurtling through space. At the very center of every bright comet lies its heart, a solid core called the nucleus. This is the dirty snowball itself. When a comet is far away from the sun, in the cold, dark outer solar system, the nucleus is all there is. It's a dark, lumpy object, often blacker than coal and hard to see. Its surface is a mixture of ice, dust, and rock, all frozen together at temperatures hundreds of degrees below zero. You can think of it as a cosmic fossil, a perfectly preserved piece of the ancient cloud of material from which our sun and all the planets were born. Over 4.5 billion years ago. The sizes of these nuclei can vary enormously. Some are quite small, maybe the size of a few city blocks, or a small mountain, perhaps a few kilometers across. Others are much, much larger, tens of kilometers in diameter, bigger than a large city. To truly understand a comet, we need to look at what it is made of. The recipe is surprisingly simple, yet it holds the key to the formation of our entire solar system. The main ingredient is ice. But not just the frozen water ice you find in your freezer. Comets contain a cocktail of different frozen gases: frozen carbon dioxide, frozen ammonia, frozen methane. These are solids only in the incredibly cold outer solar system, far beyond Neptune's orbit. That's why comets are often called dirty snowballs. Mixed in with all that ice is a significant amount of dust and rock, tiny rock particles and dark, carbon-rich organic compounds. These organic molecules are the chemical building blocks of life: carbon, hydrogen, oxygen, nitrogen. As our frozen nucleus journeys inward toward the sun, the star's warmth begins to have a dramatic effect. The ice on the comet's surface doesn't melt into a liquid. It turns directly into a gas. This process, called sublimation, creates a huge, fuzzy cloud that surrounds the solid nucleus: gas and dust. This cloud is called the coma. While the nucleus itself might only be a few kilometers across, the coma can grow enormous, often larger than the planet Jupiter. It is this glowing coma that makes a comet visible to us, appearing as a bright, hazy ball of light in our telescopes, and sometimes to the naked eye. The coma is essentially the comet's temporary atmosphere. It is a chaotic, expanding bubble of water vapor, carbon dioxide, other gases, mixed with fine dust particles once trapped in the ice. The sun's ultraviolet light energizes these gas molecules, causing them to glow, much like a fluorescent light bulb. From Earth, we don't see the tiny nucleus hidden inside. We see a vast, glowing halo of light. If you could fly a spaceship through the coma, you'd likely not even notice it. You'd see the tiny nucleus ahead and glowing gas all around you, but you'd feel no pressure or resistance. As the comet gets nearer, it heats more, causing more ice to sublimate and the coma to grow larger and brighter. As it moves away, the process reverses. Two Tales of Wonder. One of the most spectacular features of a comet is its tail, or more accurately, its tails. As the comet gets close to the Sun, it doesn't just form the glowing coma. It also develops two distinct tails that can stretch for millions of kilometers across space. These tails are what give comets their iconic appearance as they streak across our night sky. They are not trailing behind the comet like the smoke from a train. Instead, they are pushed away from the comet by the power of the Sun. This means that a comet's tails always point away from the Sun, regardless of which direction the comet is traveling. The first tail is called the dust tail. It is the most visible and often appears as a broad, curved, and yellowish-white trail. This tail is made of tiny, solid particles of dust, the dirt from the dirty snowball, that are pushed out of the nucleus along with the gas. These dust particles are relatively heavy, so they are not pushed away by the Sun as forcefully as the gas. They tend to follow the comet's orbital path, creating a gentle curve behind it. The second tail is the ion tail, also known as the gas tail or plasma tail. This one is often fainter, straighter, and has a distinct bluish color. It is made of gas particles from the coma that have been electrically charged by the Sun's ultraviolet light, turning them into ions. These charged particles are then caught and pushed directly away from the Sun by a stream of charged particles flowing from the Sun called the solar wind. Because the solar wind is powerful and moves very fast, it pushes the ion tail into a perfectly straight line, pointing directly away from the Sun. The blue glow comes from charged carbon monoxide molecules shining brightly. Sometimes, when a comet is moving away from the Sun, its tails can actually appear to travel in front of it, a celestial weather vane showing the direction of the solar wind. A comet's journey through the solar system is not a straight line, but a long, looping path called an orbit. This path is controlled by the immense gravitational pull of the Sun. Unlike the nearly circular orbits of the planets, most comets follow highly stretched-out, oval-shaped orbits called ellipses. This means a comet spends most of its life moving very slowly in the cold, dark outer solar system, far from the Sun. Then, for a brief period, it swings in close to the Sun, speeds up dramatically, and slingshots back out into the darkness to begin a long, slow return. We can group comets into two main categories based on orbit length. First, short-period comets. They take less than 200 years to orbit the Sun. They come from icy bodies beyond Neptune, the Kuiper Belt. Giant planets can nudge them out, Neptune and Jupiter, sending them inward. These return within a human lifetime. Second, long-period comets. They take thousands or even millions of years for one orbit. They come from a vast spherical cloud surrounding the solar system called the Oort cloud. That cloud extends perhaps a quarter of the way to the nearest star. Occasionally, a passing star or the galaxy itself disturbs an Oort cloud comet and sends it toward the Sun. Think of a comet's orbit as a cosmic roller coaster. A long, slow climb in darkness, racing down near the Sun, whipping around at closest approach, then climbing back up and slowing as it recedes, transforming a dark, frozen rock into a brilliant spectacle of light and gas that graces our skies. Among the thousands of comets we know of, a few have become famous for their spectacular appearances in our skies. Perhaps the most famous of all is Halley's Comet. It is a short-period comet, returning to the inner solar system about once every 76 years, which is just about a human lifetime. This regularity means it has been observed and recorded for more than 2,000 years by ancient Chinese, Babylonian, and European chronicles, often seen as a significant omen. It is named after the English astronomer Edmund Halley. He realized that sightings in 1531, 1607, and 1682 were of the same object. A comet nucleus, a very dark surface, a peanut-shaped nucleus, and a surprisingly active surface with bright jets of gas and dust erupting from only a few small areas. Another famous visitor, Comet Hale-Bopp in 1997, a magnificent long-period comet, one of the brightest seen in decades. Visible to the naked eye for 18 months, longer than any other recorded comet. Its nucleus was about 60 kilometers across. It produced a tremendous amount of gas and dust, creating a brilliant bright coma and two very distinct tails. A fascinating discovery. A faint sodium tail, long and narrow, stretching approximately 50 million kilometers, revealed by special instruments, showing comets are even more complex and surprising. Comets are not eternal. With every fiery pass around the sun, they lose a part of themselves. Each time a comet heats up, some of its ice turns to gas that escapes into space, carrying dust with it. This means that on every orbit, the comet's nucleus shrinks a little. It's like an ice sculpture slowly melting in the sun. With each visit, it becomes a little smaller and a little less grand. A comet is born with a finite amount of ice, and every trip to the inner solar system uses up some of that precious supply. Over thousands of years, over millions of years, this gradual loss will eventually end the comet's active life. Sometimes, the end can be far more dramatic. The nucleus is a fragile, loosely packed body. Rapid heating as it nears the sun and strong gravitational forces can make the nucleus break apart. We have seen comets disintegrate. A comet can shatter into several smaller pieces, each becoming a tiny comet for a short time before they fade away. Breakups turn a comet into a cloud of icy debris that disperses along its old orbit. If a comet survives long enough, it may run out of volatile ices. After countless trips, frozen gases near the surface sublimate away. What remains is a dark, rocky, dusty core with no ice to power a coma or tails. The comet becomes dormant or extinct. It no longer lights up approaching the sun. It continues as a dark, asteroid-like object, a ghost of its former self. Some near-Earth asteroids may be dead comet husks. The material lost from comets doesn't vanish. Dust and small rocks spread along the comet's orbit, creating a debris stream. If Earth crosses a stream, we get a meteor shower. Tiny particles burn in our atmosphere as shooting stars. The Perseid meteor shower in August returns every year when Earth passes through the debris trail left by Comet Swift-Tuttle. Even after a comet dies, its legacy still lights our night sky. From a sudden bright visitor in the night sky to a dark, tumbling nucleus of ice and rock, the story of a comet is a journey of magnificent transformation. We have seen that these celestial travelers are essentially dirty snowballs, leftovers from the birth of our solar system. We have learned that their solid heart, the nucleus, is surrounded by a vast, glowing cloud called the coma when warmed by the sun. This warmth also creates two magnificent tails, a curved white dust tail and a straight blue ion tail, both of which always point away from our star. These wanderers travel on long, looping orbits, bringing them from the frigid outer darkness into a brief, fiery dance with the sun before they retreat once more. We've met famous examples like Halley's Comet, a reliable visitor, and the brilliant Hale-Bopp, which captivated the world. Each pass near the sun costs the comet a piece of itself, meaning that all comets must eventually fade, break apart, or become dormant. dark echoes of what they once were. They are cosmic time capsules, carrying the chemical secrets of our own origins, and may have even delivered the building blocks of life to our own Earth. Here are a few key things to remember about these cosmic snowballs. 1. A comet's core is a dirty snowball of ice, rock, and dust called the nucleus. 2. As it nears the Sun, it forms a giant gas cloud called a coma and two tails. 3. The dust tail is curved and white. The ion, gas tail, is straight and blue. 4. Comet tails always point away from the Sun. 5. Comets have long, oval-shaped orbits and lose material with every pass by the Sun. The study of comets is a study of our own history, written in ice and dust. The next time you see a picture of a comet, or are lucky enough to spot one in the sky, take a moment to appreciate it. You are seeing a message from the beginning of time. What other secrets are locked away in these frozen time capsules? I hope you like our stories of the skies. Until we meet again, I wish you a clear sky.